this is Pete from PA Labs. We're going to add an element to fringe. We're going to initialize the fringe linked hex. The linked hex is the 6 surrounding hexes inside him. And then we are setting our first fringe to equal start. Okay? And the fringe cost to get to there is 0, right? So we've got our very first fringe is now set up. So now we're going to start and iterating from record 1. Remember, in lists are 0 based, so we start with 0 and then 1. Okay, so what we're going to do is say K equals 1 to total movement. We are then going to say, because we're iterating movement, okay? Now, movement's going to change in a lot of different places because as you move, it may cost you 2 points to get there, okay? So, now, actually, I don't know. I think I actually let him go all 6 or whatever he is. But I think when you run out of movements, I just stop. So anyhow, we're going to add another new fringe. So now we have the fringe collection now has a second record. And we're going to move to that record. So now we have fringe 0, which is our starting location. And we are sitting on the list at 1, the new guy. And we go ahead and initialize his linked list. Okay? Now, what we're going to do is loop well, let's just keep moving. I don't want to get ahead. Now we want to say select element fringes K minus 1. Think about that for a second. K minus 1 is 0. So we've now selected our start record, fringe record. So we've selected fringe 0. All right. So what we're doing is we've selected this hex and fringe is now on fringe number 2. And what we're going to do is now spin these guys, and we're going to create and we're going to load these 6 fringes into fringe 0 and then also create a fringe for all 6 of these guys. Okay? Now watch how that happens, because we're doing 2 things at once. That's part of what makes this ferociously confusing. And that's why literally every single line in here has a comment for you. All right, so we're selecting fringe 0, which is our starting hex. We then say, okay, for X, new iteration, we're going to go list size fringe linked hex, from the list size from 0 to the list size, and this is the children. This is the linked list inside fringes. We're going to select the linked list X. We're going to update. This is our cumulative variable of movement. And right now, he's just being set to the cost of, okay, so we're here. We're going to select a hex out of these 6. And we're saying, if I move here, now we're got 2 points here, all right, of movement. And we're going to come into this and say, fringe. Now we're going to look at the surrounding hexes. So we're looking at fringe 0. Fringe 0 is this guy here. And the only linked hex he has is start. All right. So the only in fringe 0, his collection of lists of surrounding hexes is only himself. Okay, so we're going to start with this square and his movement cost, which is 0 because he already owns the square. And we're going to spin the 6 directions now and look these 6 hexes up. Okay, so here's where we're spinning 0. Whoops. This is going through the fringe 0's linked hexes, which only contains himself, that one starting hex. And then we're going to spin the directions 0 to 5. We're going to create a neighbor hex, and we're going to say hex neighbor fringe hex. That's the hex of our starting point. Here's the direction, create me my neighbor. So this function jumps through all of those functions up above and loads this neighbor object with whatever direction 0 happens to be. Okay, so now we have a neighbor. Now we're going to step in and say, have we already visited this particular hex before? To do that, we spin through the visited list of hexes and we say, do we have somebody in here that exactly matches this hex? If we do, we flag it as found. We're done looking. Only if we get through all of them do we come down here to not found. Okay, so here's the math where we make sure we're not moving off the grid, off our map. Okay, that was our bad pointer in one of the videos. I had actually moved too close to the edge and this went off the map. So it went to a negative number and you can't get there. So this was part of the tweak code to fix that. I then go look up the terrain cost of this cell based on my unit's element type and his row and column. Okay. Now let's go ahead and jump in and let's look at the movement cost lookup. This is where we tie into the first video. So in the movement cost, oh crap, I bet you jumped. No, you jumped right. Okay, so we have an element type. That's our infantry, armor, artillery, boat, what have you. We have his row and column. Well, that's important because now we're going to go get the terrain. First we're going to spin the terrain rules, and we didn't look at those, but they're there. We'll get back to that, I guess. Okay, so we're going to look at the terrain rules for this element type, and we're going to say, you're going to select it, and then we're going to say, okay, if the terrain category is terrain category, which is your when you set up a rule, you set up a rule for infantry for a terrain category of foliage, and then the cost of movement is 2. Okay, so what that is how this is looking up. The rule itself contains the category, and then there's various things you can have. Movement type is 1. Okay, so the movement cost is that we're going to grab the movement cost and we're going to set the variable max to the movement cost and return our movement cost for that unit in the terrain of that cell. Okay. Where were we? Here we are. Let's see. So that gets us the terrain cost of that particular cell. Now, here is where we're coming into the terrain grid. We're doing a lookup into the terrain grid again, row and column, and we're looking to see if it's a blocked cell or is it a zone of control, okay? because those affect movement. So what we have is our tracked movement, which was the original movement of the fringe, plus the terrain cost we just looked up. If that is less than and equal to the movement that this unit has the capability of, we're golden. He can move there. Then we say, okay, let's add this cell to visited. So we add him to visited. So visited is now updated. And then we're going to say, okay, if he's in a zone of control, then what we want to do is set his terrain cost for this particular cell to be all of his terrain, his movement capabilities. So if he moves to that cell, he's done moving. Otherwise, we just increment it by the terrain cost. He's not moved into a zone of control. All it is the 2 points of movement. Okay, now comes the fun parts of this. So we've added it to a visited. Now what we want to do is create a new fringe of this particular hex and put him, that neighbor, in as the first of the linked hexes of that fringe. So he's now the new center point of the next fringe that we're going to zip around the exterior of 6 squares. Okay? And then we set the fringe terrain cost to the track movement. This is adding up our cumulative movement to get to that particular fringe cell. And then we actually, since we have just now moved our linkage inside the list from 0 to 1, I'm going to move us back to 0, just putting us back where we were. And then we're going to loop back up and we're going to go to the next of the directions. So we're going to do that loop for all 6 directions. So at the end of the first cycle of directions, we then will have, assuming you're not leaving a map or you got all 6 directions, you will have 7 fringe records in the fringe list. You have your original starting, and then you have the 6 surrounding hexes as fringe hexes, each one loaded with itself as the center hex. Okay? Now, this is where this gets freaky. So we've finished all of that. Our fringe, our first level 0 is done because there was only 1 hex in him. We're done with him. He comes up here and he says, okay, we increment K. So now we're on our step 2. We come down and now we're going to skip 0 and we're going to look at fringe 1. We just added fringe 1, 2, 3, 4, 5, and 6. Okay? And after this one runs, we're going to add 6 more fringes. You see how this is building this array of, or a list, which each record in the list is an array of the 6 hexes that surround that hex. All right? So that is how Flood-Fill works. And it's kind of hard to wrap your head around, I admit. That is why I've detailed this out so heavily for you to track. But I will put this, I don't know where I'll put this. I'll put this, I guess, on the website for Flood-Fill. And you can add these 2 videos to your list of videos to watch. I know this one's pretty big, but the first one sets it up, and this one really kind of puts it all together for you. Everybody, this is Pete from PA Labs, and this is a quick middle of the road sort of video. I'm going to inject into the deep dive of the flood fill. In the previous video, you actually saw MapMaker do something it's not supposed to do, and I've spent the last 30 minutes looking at it and cannot for the life of me figure out how it did what it did. But all is not lost. It hasn't physically done anything with your map. It just screwed that image up. I have to think it has to do something with pointers and with the variable ID that I'm probably reusing. And the way to fix that, it hasn't changed anything. Everything in your map is fine. Come out here to change. Add a column or a row and tell it to convert the map, and it will re-image the entire map structure to add the new column. There's no other way around doing that. So we add a column that will completely rebuild your map, and then you can actually come out here and delete the column and put it back to the way it was, and you've overcome the issue with the map that we had. Okay. And I am still searching for that bug. I'll find it eventually. Okay, so the purpose, other than that, of this particular video was to dive real quickly into the unit movement costs. Okay, and I wanted to show you where that was from. In the video, I totally, completely drew a blank. And so this is kind of an oops, I'm going to fix that. And so where you create your unit costs for foliage and all of that stuff is actually in the game creator. And hopefully it's coming up here. There it comes. Okay, so in the Wargame Creator module, this is part of the Wargame deployment package. You have Creator and you have the player. So we can come in here and design our game. And I want to show you where this is all coming from. So if you go to the Terrain tab, you can see all of the terrain that exists, all of the, well, these are where I've actually created rules. Okay, so this is by element, artillery, foliage. So artillery, and then you come out here and you have the element type, the terrain type, you have movement cost, defense, or attack effect. And then what is the effect? 2 points, 1 point negative, whatever. So this is saying for movement costs, it costs artillery 2 points to move through foliage. And then artillery, I kind of penalized artillery everywhere it went. And just to try to create some rules that said, this is, if he's in grass, it still costs them 2. So if you look at the function that's coming up, where he's looking up the terrain cost, he spins all of these terrain rules for the specific element and saying, okay, I've got road, I've got grass, I've got foliage. And at the moment, he's pulling the highest cost. I probably should reverse that and say pull the lowest cost. But yeah, that's just something. This is where the rules of the game come from. You can come out here and create the rules as you see fit, and the code will then pick it up when you're in that module. And I also wanted to point out that I'm going to go ahead and update the code or the website with the code from these um, flood fill videos. I'm going to go ahead and put a block out there just to download for that single code sheet that we went through and the picture and that sort of thing for you to review so you can lay your hands on it and see and walk the code yourself. So that really ends off the whole series of flood fill, the super deep dive. And I want to thank you as always for watching. I want to thank you all very much for watching.